All right, guys, any questions over the homework? Any questions on any of the homework assignments thus far? All right. What we're looking at today is simplifying complex fractions. So there's two main methods for simplifying complex fractions. One of them is simplifying the numerator and denominator, the top and bottom, so that they are only a single fraction, and then dividing by multiplying the numerator by the reciprocal of the denominator, or just dividing the top and bottom. Or we can multiply the top and bottom by the least common denominator and then simplify where necessary. So what we're doing is we're taking this here and simplifying it down, because we cannot have a fraction or multiple fractions on top and bottom of the fraction. So we need to simplify this to one fraction. And to do that, the first main method, or the first method, is to rewrite the denominator as a single fraction, because we need one fraction on top and one fraction on bottom. We can only have one on top and bottom. Now to do that, we need to simplify the denominator into a single fraction by adding the two together. And for us to be able to add or subtract these two fractions, we need the denominators to be the same. And to get the denominators to be the same, we need to multiply both of the fractions, possibly both, at minimum one, by something to get them to be the same. So we've done this before with finding the least common denominator of what we need this here. We've also looked at seeing what does one have that the other doesn't. Now the one on the right is x, and it's missing the expression x plus 4. So we're going to have to multiply it, the one on the right, by x plus 4 over x plus 4 to get the denominators to be the same. The one on the left has the x plus 4, but it's missing x. So we're going to have to multiply the top and bottom of its fraction by x over x. Now we're not worried about the numerator of this whole fraction because it is a single fraction. Because that's the whole goal right now, is to get one fraction on top and one fraction on bottom. Now we do this multiplication on bottom. For the one on the left, we're going to multiply the x and x plus 4. And just like with our addition problems, we're not going to distribute through, because the main thing is that we need the denominators to be the same, not so much combining like terms. So we can leave it as x times x plus 4. On top, we're going to multiply x and 1. And 1 times x gives us 1x, or just x, plus our other denominator. We multiply the x and x plus 4 gives us x times x plus 4. Now on top, we can distribute this fraction, or this 2 out. So when we do that, right here, 2 times x is going to give us 2x. 2 times positive 4 is going to give us plus 8. Questions on this so far? So really the whole goal of this and what we've done so far is to get the denominators to be the same. Now that they are the same, we can add the numerators together. So we're going to be adding the numerators x and 2x plus 8. Now, we can put parentheses around both of the numerators, but again, because we're adding positive terms, there's no sign change, there's nothing that's going to change there, so we don't necessarily need them for this one here. Last thing we need to do on bottom is combine like terms. So x plus 2x is 3x. We still have the plus 8 over x times x plus 4. And there. Questions on how we got to this point? Now, the whole goal of doing the addition and doing that, all of that on bottom, was to get us to have one fraction on top and one fraction on bottom, so that we can simplify from here. Because realistically, when we have a fraction, really what it's telling us is that we have the numerator, which is our 5 over x plus 4, is being divided by our denominator. And really, any fraction is just saying the top divided by the bottom. It's just a way to write it. Especially if whatever the numerator is not divisible or evenly divisible by the bottom of the fraction, we can leave it in fractional form. So really our 5 over x plus 4 all over 3x plus 8 over x times x plus 4, we can think of it as 5 over x plus 4 divided by 3x plus 8 over x times x plus 4. Now we're just looking back at our division problems. And the main way we divide fractions is that we keep the first one the same. We change it from division to multiplication and flip our second expression. So now we're really just looking at a multiplication problem. And we multiply the numerator. 5 times x is going to be 5x times our x plus 4. On bottom, we can leave this here as x plus 4 times 3x plus 8. Questions on how we got to this point? Is there something in common on top and bottom? Yes, the x plus 4. And since they're being multiplied, x plus 4 and 5x on top, x plus 4, 3x plus 8, we can simplify the x plus 4 over x plus 4, leaving us with 5x on top and 3x plus 8 on bottom. Now, because of the plus sign between the 3x and 8, they are stuck together as one term. We can't just simply break them apart. So the only way we can simplify from here is if there is something we can factor out of the bottom that would reduce with something on top. However, 3x and 8 do not have any like terms. This is actually as simplified as it gets. Questions on this here? Realistically, there isn't a lot we're doing. There's a lot of steps, but I wouldn't necessarily say that there's a lot involved with this here. Questions on this first method? I have a feeling it might have taken up most of the page. We're going to do this again, but put it under the space above the problem. Because the other method to solve or to simplify uses least common denominator. We want to find what the least common denominator of the denominators of the numerator and denominator of this fraction. So we're looking at that for least common denominator. Here we're looking in 3 spots. We're looking at the denominator on top, which is x plus 4, and the 2 denominators on bottom, which are x plus 4 and x. We're trying to find its least common denominator. Well, the expression x plus 4 shows up in 2 different places. But how many times does it show up in each one of those places? Once. So for the least common denominator, we're only going to need it once. Even though it does show up twice, for least common denominator, we only need it once. So that takes care of the top fractions, part of the least common denominator, one of the bottoms. What other term do we need? We need the x, because it does show up in one of the denominators once, so we only need it once. Questions on how we found the least common denominator? Now what we're going to do with it is we're going to multiply this entire fraction by x times x plus 4 over x times x plus 4. We're going to multiply the top and bottom of this fraction by this expression here. Now for this one here, I'm going to write it out a little bit more than we really need. Because on top of this fraction, the 5 over x plus 4, we're going to multiply it by our x times x plus 4. We're going to be multiplying this top fraction by x times x plus 4. We're also going to do it to the bottom. So our 1 over x plus 4, this fraction is going to be multiplied by our x times x plus 4. Plus our 2 over x is also going to be multiplied by this x times x plus 4. Because we're distributing it to every term on top and every term on bottom. Now realistically, this is going to be the last time we write it out this way, because when we multiply a fraction by this expression, x times x plus 4, the denominator of this is understood to be 1. So on top, really what this x times x plus 4 is being multiplied is the 5 on top of the fraction. Because we're really multiplying the x times x plus 4 by the numerator of the numerators and the numerator of the denominators, because we're multiplying it on top. Questions on this here? Now on bottom, our x times x plus 4 is going to be multiplied by 1, telling us that we get x times x plus 4 over x plus 4. And our last one, the x times x plus 4, is going to multiply with the 2. Almost forgot the x plus 4 on top. Questions on this here? Thank you. Sounds good. Throw it on my desk. Questions on how we got here? All right, guys, focus in, focus in. Now, for the most part, this seems like we've made the expression a little more complicated than the other one did. But let's look at the top. Our top fraction, the x plus 4 over x plus 4 will simplify. And what that leaves us with on top is, well, we do have 5x, but because the denominator also simplified, the x plus 4 with the x plus 4 on top, the only thing we have left on top is 5x. All the fractions on top simplified out. We might get more than one term, but the big piece is that we don't have another fraction, or do not have fractions on top of this fraction. On bottom, the fraction on the left, the x plus 4 over x plus 4 will cancel, leaving us with x. And lastly, because we have 2x over x, well, the x with the 2x on top and the x on bottom will simplify out, leaving us with plus 2 times x plus 4. So realistically, by multiplying by that least common denominator, we simplified all the fractions on top and bottom to two expressions, one on top, one on bottom. Questions on how we got to this point here? Now, the only thing we have left to do is actually just simplify the numerator and denominator. Now, the numerator is just 5x. There's nothing we can do with it. There are no like terms, no factoring. But because of this 2 times x plus 4 on bottom, we will need to multiply it out. Our 2 times x is going to be positive 2x. Our 2 times 4 is going to give us plus 8. And x plus 2x gives us 3x, telling us it's 5x over 3x plus 8. Questions on this here? I think this other method is a little bit nicer in the long run because we're able to simplify these fractions a little bit nicer. We're not having to combine like terms. And it becomes very nice, especially when we start getting multiple expressions on top and bottom. So with this next one here, we need to see what we need to multiply the top and bottom of this fraction by, the least common denominator, to get those fractions to simplify out. You simplify those fractions completely. Well, the 3 expressions we're looking at, one of them is x minus 2, one of them is x minus 2, and the other one is x. So x minus 2 does show up in 2 different places, so we do know we'll need it at least once. Do we need it a second time? Well, no, because it only shows up once in each of the denominators. Even though it shows up in 2 different denominators, it only shows up in each one of them once, so we only need it once. Is there anything else we need? The x. To simplify with our last denominator on bottom. Questions on this here before we go to the next step? Now what we're doing when we do this here is we're multiplying x times x minus 2 by each numerator on top and each numerator on bottom. So the top fraction, 6 over x minus 2, we're going to multiply that x times x minus 2 by the 6. Yeah, the Kleenex is, for some reason, whatever the perforator or what caused it to tear between each sheet did not fully tear, so it's going to the next one. It's weird. They were cheap. Questions on the top? Now we're going to do a similar thing on bottom. So our x times x minus 2 will multiply with the 1 on top of our first fraction, which is just going to give us x times x minus 2 back, plus, then we're going to multiply it by the 3. Now the 3 in x, you're going to have 3x times x minus 2 over x. Now at this point here, especially if we have 2 expressions being multiplied together, x minus 2 times x plus 2, or any of those there, I would just rewrite them out parentheses next to each other, especially on top of the fractions. One, because as we see with this here on top, the x minus 2 over x minus 2 will cancel. Now we could have done 6x times x, giving us 6x squared minus 12x, but then for it to simplify, we have to factor it back out. So it doesn't actually help us to multiply there. On bottom, the first fraction, we have x minus 2 over x minus 2 canceling. And in the other one, we have the x and x. And what that leaves us with is 6x on top. On bottom, we have x plus 3 times x minus 2. questions on how we got to this point here? Now we do need to finish simplifying, so we will have to distribute that 3 through. 3 times x is 3x. 3 times negative 2 is negative 6. 3x and x give us 4x, telling us that we have 6x over 4x minus 6. Now, before we can say that is the final answer, we just need to make sure nothing factors, nothing simplifies. Now, the 6x and 4x won't just simplify. 6x on top is fine because it's 6 times x. But our 4x minus 6, those two are stuck together because of the subtraction. So we can't just cross those out. As much as we want to go here, even reducing the 6 and 4 doesn't help. But if we look at the bottom of the fraction, 4x and 6, is there a greatest common factor between these two terms? There is, and it is 2. And if we factor 2 out of 4x, we're going to be left with 2x inside. And if I factor the 2 out of 6, we get 3. Now, even if that doesn't reduce or simplify, we still want to factor it as far as possible to make sure that nothing does. However, now we do have a product on bottom, the 2 and our expression 2x minus 3. And 6x on top is product 2, which means we can actually simplify this 6 over 2. Because they have a greatest common factor of 2. So the 6 on top is going to become 3. The 2 on bottom is going to become 1 or simplify out, leaving us with 3x over 2x minus 3. Questions on this here? Are you ready for the next one? X over 6 minus x over 3 over x minus 5 minus 7/10 over 10. So again, I think the second method's a little bit nicer with just being able to multiply by something, so we're not trying to get fractions be the same, then change it to division, then flip it. It works a little bit nicer. Now at this point here, we're trying to find the least common denominator between 3, 6, 5, and 10. You all have a guess at what the least common denominator is going to be. So we're trying to find the first number I can turn. Well, let's look at the least common denominator for 3 and 6. What's the first multiple of 3 and 6 that they are the same? 6. How about 5 and 10? 10, yes? So we can look for the least common denominator of 3, 6, 5, and 10, but really what are we looking for the least common denominator of? 6 and 10. Because 3 and 5 are prime. 6 is just 2 times 3. 10 is 2 times 5. So if we do the prime factorization, or our multiples, to find the least common denominator, 2 shows up as a factor for both 6 and 10. But it only shows up in each one of them once, so we only need it once. 3 is a factor of 3. It's also a factor of 6. Each one of those, it only shows up once. So even with 3 and 6, we know that the least common denominator is 6. What is the only other factor we have is 5. It only shows up once, so we only need it once. 2 times 3 is 6. 6 times 5 is 30. So our least common denominator of this whole fraction is 30. So So we can multiply the top and the bottom of this complex fraction by 30. And if we do this, on top, 30 times x is going to be 30x over 6 minus 30 times x is 30x over 3. Thirty times x on bottom, we'd have 30x over 5 minus 30 times 7 is 210 over 10. So really the only thing that actually simplified or multiplied to something different is 7 times 30. But again, we just need to simplify. 30 divided by 6 is 5. We still have our x. Minus 30x divided by 3. 30 divided by 3 is 10. We still have the x. 30x over 5. 30 divided by 5 is 6x. Minus 21. 210 divided by 10 is 21. Questions on this so far? 5x minus 10x, those are like terms. 5 minus 10 would be negative 5x. 6x minus 21, 6x and 21 are not like terms. So we do get negative 5x over 6x minus 21. Negative 5x on top, it's a single term, so there is no greatest common factor, nothing we can do with it there. 6x and 21, we do have two terms, so there might be something. The degree is 1, so we can't do our normal 2 sets of parentheses with 3 spaces. But is there a greatest common factor between 6 and 21? Yes, and it is 3. And we can factor it out. And if I factor 3 out of 6x, 6 divided by 3, I'll have 2x minus 7. Five x and 3 do not simplify. So this is the final answer. Even though there is no thing, or there's nothing that simplifies, we still want to leave it in factored form. There's no reason to get to this point, see that there's nothing that simplifies and multiplies the 3 back through. This is our final answer. Questions on this here? Two over x minus 4 all over 2 over x plus 3. How many denominators in the numerator and denominator do we have? Well, we have this one here, yes? And this one here. Are we concerned about the 4 and 3? No, because the whole goal is to get one fraction. No fractions left on top or bottom. And the only place that we actually have a denominator is our 2 over x on top and the 2 over x on bottom. And the only thing in those denominators is just x. And we only need one of them because only one of them shows up in either one. So now all we need to do is actually multiply this here. Now for our fraction on top, x is going to multiply with the 2 and give us 2x over x. Minus, we still have to multiply this x with the 4 because it's not written, but it's understood to be over 1, telling us that this is going to become 4x over 1 or just 4x. We're going to do the same thing on bottom. Our 2 and x are going to multiply, giving us 2x over x. And we're going to multiply with the plus 3, giving us plus 3x. Questions on how we got to this point here? Now on top, the x and x will cancel, telling us that we have 2 minus 4x. Again, on bottom, the x over x will cancel, giving us 2 plus 3x. Now, there is a greatest common factor on top. And that greatest common factor is 2. And that's as far as it goes, because it feels like we did the factoring of 2 on top, and that 2 on top and the 2 on bottom might simplify, they might reduce out. But because the 2 on bottom is being added to the 3x, they're stuck together, they're one term. Now, we could rewrite it with the x in front. And it would look like this here. They are the exact same. There is no difference. Questions on this here? Now we need to simplify the fraction on top and bottom. What is one of the expressions we need to multiply by? What? X plus 5, yes. Anything else? X minus 3. We're going to multiply by x plus 5 and x minus 3. Now on top, we're going to have to multiply the x minus 3 times x plus 5 by 3. Now for this here, I'm not going to distribute out yet, because we do need to simplify, we do need to reduce on top and bottom. So it's better to just leave it and then reduce later. Because we're going to do the same thing on bottom. We're going to get 2 times x minus 3 times x plus 5 over x minus 3 plus we're going to multiply the x minus 3 times x plus 5 by 1, giving us x minus 3 times x plus 5. Now that we have this all multiplied out, for the most part, we can do simplifying on top and bottom. So the numerator all we have left on top is 3 times x minus 3. In the first fraction on bottom, the x minus 3 and x minus 3 cancels, leaving with us with 2 times x plus 5. In the last fraction, the x plus 5 and x plus 5 cancel, leaving us with plus x minus 3. Questions on how we got to this point here? Now we need to simplify and solve, yes? Looking at the bottom of the fraction, we do have 2 sets of parentheses. The first one, 2 times x plus 5. The other 3 are just x minus 3. There's a good chance there are going to be like term stuff that we have to combine and simplify, yes? On top, we do have 3 times x plus x minus 3, yes? Is there anything else on top? Is there anything I need to combine with the x or 3 or like terms? So is there any reason for me to simplify or multiply that 3 through? No. Now if we had, say, plus 4. Okay, I'm going to have to multiply through by the 3 and then combine like terms with the 4. But this here, 3 times x minus 3, is already in factored form. It's already simplified. There's nothing I need to do to it. Now, because there is a possibility of like terms on bottom, we are going to have to simplify. And as we multiply through by the 2, 2 times x is 2x, 2 times 5 is 10. In our second set of parentheses, those parentheses are just going to drop. We get x minus 3. Now our 2x plus x is going to be 3x. Our 10 minus 3 is positive 7. Now our 3x plus 7, again, we got to remember that is one term, that's one expression. So that 3x on bottom and the 3 on top won't just simplify out. 3x plus 7 has no like terms. There's nothing we can do, reduce. There's nothing we can do with it. That is the final answer. Questions on this here? Let's look at this one next. 1 over a minus 3 over a minus 2. All over 2 over a plus 5 over a minus 2. We're going to need to multiply the top and bottom of this here by 2 expressions, or 2 things. What's one of them? A minus 2. What else? A. Because we need the single a from here and here, and we need the a minus 2 for each one of these here. Now, because a minus 2 doesn't show up more than once, or a, because if we had a squared, we would need a squared. We need 2 of them. But since it only shows up once, in each one of those spots, we only need it once. And now that we have this set up, we can multiply through. Now our a times a minus 2 is going to multiply with the 1 on top, making the first expression be a times a minus 2 over a. Minus, we're going to have to multiply that a times a minus 2 times 3, giving us 3a times a minus 2. On bottom, we're going to do the exact same thing. Our 2 times a is going to be 2a times a minus 2. On bottom is just going to be a. And lastly, we're going to multiply it with the 5. Now, in the first fraction, the a over a will simplify, leaving us with a minus 2. Second expression, the a minus 2 over a minus 2 will simplify, leaving us with just 3a. On bottom, the a over a will cancel, leaving us with 2 times a minus 2 plus last spot should just be 5a. Now in the numerator, we can drop our parentheses. Really, we're going to have a minus 2 minus 3a. On bottom, 2 times a is going to be 2a. 2 times negative 2 is negative 4 plus 5a. a minus 3a is going to be negative 2a. We still have the minus 2. 2a plus 5a is 7a minus 4. Now the numerators, negative 2a minus 2, they do have a greatest common factor of negative 2. I'm taking the negative out because both terms are negative. 7a minus 4 does not have any like terms, so that's actually as far as it goes. Questions on this here? You know what? We'll finish these last few tomorrow. Dig into some of these here, because some of them, it does take a little more time, not so much because of the problems themselves, it just takes a while to write them out. Just like with our addition and subtraction,